All right, so I'm talking about my library that I've been calling Clein or Clean when I forget. And it's the title of the talk is Bringing a Bit of Leiningen to deps.edn. And I just want to highlight at the beginning that I made this with the Skittle Tiny Slides app. It's really, really nice. All right, so who am I? I'm Noah. I live in northern Kentucky in the United States of America, which is kind of like what they call the Midwest, even though it's more on towards the east of the country. I've been doing Clojure for a long time, and I work at a place called Relay Network as more of a back-end developer, but I've been doing a bit of front-end as well. All right. So what else have I done? Before we get into Clein, my first and kind of, I think, biggest library is called Splint. It's a Clojure linter that's focused on style and code shape. I based that one on Rubocop from the Ruby community and on Kibit from Clojure, the older kind of like use this, not that, or there's a function for that. And I've also been working on Lazy Test. Lazy Test is an old alternative to Clojure.test that was originally developed by Sandra Sierra back when she was kind of contributing to Clojure. She's the one who wrote Clojure.test for Clojure 1.1 and then was frustrated with it and started working on Lazy Test and then kind of ran out of steam and moved on to other stuff in 2013. And so back in 2023, I picked it up because I was also frustrated for many of the same reasons and decided to develop it out some more. And so that's a fully functioning alternative to Clojure.test that I think is pretty sick. Maybe I'll talk about that someday. So what is Clein? So Clein is an attempt to bring some of the configuration-based building and development workflows from leiningen to deps.edn or the tools.build projects. What that means is instead of building a build.clj, writing a build.clj file, and then executing it, with like Clojure-t, build, etc. You run it like a normal alias, right? Clojure-m, and then pass in your arguments. And the goal, compared to some like these similar projects that exist, like build.simple, which is really nice, or Liquids, build.edn, Liquids, they do amazing work. Both these folks do amazing work. But both of them also put their configuration in separate files. And my goal was to co-locate the configuration in the deps.edn file. So you would have an alias, right? Like Clein, and you have the deps, and you have the main ops, very normal. You run it with -m Clein, and then you pass whatever you want in. And then you have the alias for Clein that we've specified, or I've specified, Clein/build. And within there, it has all of the information that you would need to build something. And my goal here was to kind of mimic or be inspired from leiningen for how this works, right? So instead of having a build.clj file that says lib or def lib is whatever the symbol, and then your version is this, and then having to pass in to all of the various functions, you can just declare them. You can put them in as data into an alias. So why not stick with leiningen? Like, why am I building this? Why are we doing all this work? Leiningen is right there. To me, it comes from a couple of things. First, the community is, as a whole, moving to deps.edn. Leiningen was the premier, basically the only way to build a Clojure-focused project for many years. There were some alternatives, but they never really caught on. Even Maven is really only in the Clojure core team, and they've moved away from that to both leiningen in some respects in some of the contributor libraries, and then recently to deps.edn. And so as a whole, the entire community is kind of moving away from leiningen. And leiningen is not bad; it's rock solid, but it's also it's big. It's got a lot of baggage. It's got a lot of additional stuff that kind of makes it very complicated once you start to get into the nitty gritty. Kind of the easy versus simple dichotomy, right? It is upfront very easy, but it is not simple. There's metadata for overrides. There's hundreds of options. There's monkey patches inside that you have to deal with, like the Clojure.test monkey patch that's bitten many people. There's AOT compilation. It handles what is it? PGP encryption, GPG encryption. It handles all sorts of stuff. Like here's an example from the project sample, right? The project.clj sample that they have in Codeberg, right? Like there's AOT, but then there's also like injections. What the heck is injections? Forms to prepend to every form that it's evaluated inside your project. That's so much. Java agents, what is a Java agents, but also Java C options. Java C is good, so it's like the balance here is by putting everything into the project.clj, it has become unwieldy. And anybody who's ever tried to design a leiningen plugin will know that the what is it, eval in project macro system is it's a pain in the butt. I did not like it. So that's why we're moving away. As a community, we're all kind of saying like, actually, deps.edn is both. It's simpler, right? It's more obvious what's going on. The dependency management system is all great. I'm just repeating everything that everybody's heard, so I don't need to belabor it. Go listen to Alex Miller say all of this, but 10 times better. But so I think that there's a space for, why not use tools.build directly? And the issue with tools.build are, I think, subtler, right? Tools.build in the kind of like intro to tools.build, it says something about how building an application is an application, right? Building a jar, compiling a project is, in fact, more complicated than just being able to declare it. You need to have the power of a full language. It is a process. And I think that that's correct. I think that that's accurate. The issue is that when I started to work on a third or fourth library in deps.edn, I found myself just copying, pasting my build.clj file from project to project, just changing the names. And then I would slowly make these little edits as I needed, like for version numbers, etc. And finding myself going, why am I copying this over and over again? Why is there this like boilerplate? I have to declare the lib, I have to declare the name or the main, I have to declare the source directories and the test directories and the resources, and I have to always call clean before I'm, building my jars. Every single thing has like the same basic 4 or 5 actions that I'm going to be doing here. So why am I copy and pasting it every time? And there is, so what I've written here is like lots of boilerplate. It's too powerful. It's unnecessary for simple projects. And my experience was that the boilerplate comes from this copying pasting, right? You have to define, you need to define the basis. You need to define the main. You need to define all of the directories. And then you need to define each of the functions that the Clojure-T is going to call, right? And you have to make sure that you're setting up your options correctly that get passed into each of the different functions that the build API has, tools.build API has. And then it's because that's available to you, there's the effort that gets spent on, I don't know, nitpicking your own code, right? So do I have a function that defines a map that holds all of my options, or do I have a bunch of top-level vars that have some of the options and then just call in? Do I hard code source and ders when I call compile, or when I call, jar, right? There are all of these different options that need to happen, which leads to a lot of effort being spent on something that should just be happening behind the scenes, that should be happening below the surface, that you should never have to think about, right? Every time you have to touch a build.clj file, that's effort and time that you're not spending thinking about your application itself, about the business logic, about the bugs, about the tests, about everything that is deserving of your attention and effort. And yes, I know that there are complicated reasons, there are complicated applications that need tools.build. And so, I'm glad that it exists. But for, a smaller library, do you need it? I don't think so. Right? Here's an example from one of my projects. And I'm pretty sure everybody has seen these before, right? I've got a jar function here. It's got makeops, and makeops builds all of the things, and then it calls copy ders, and there I'm hard coding in source and resources, right? And then I'm calling jar. And then Uber is doing the same thing, makeops, copy dir, then compile, then Uber. And then I've got deploy, and here I'm using slipset's very good deploy, deps deploy, right? So delete, right palm, jar. I've written this so many times. I've copied this so many times. These are all steps that are necessary to make sure that everything works. And I'm pretty sure there's probably a bug here where jar and Uber aren't actually cleaning the necessary paths. So I might have stale classes left over, right? So why Clein? The goal is to reduce the boilerplate and cover these basic use cases, right? Cover generating a POM, cover building a jar, cover building an Uber jar, cover deploying, and very recently cover installing to your local M2 so that you can do local development. In the future, I would like to also provide, I'm trying to play with this, it's a little challenging, to provide an easy off-ramp where if you get to the point where you decide, I like the configuration that I have, and I need to have a build.clj file for, usage in a more complicated fashion, I can generate a template for you, right? It will fill in everything with all of your configuration. And the other issue is that I want to keep the configuration local and obvious, right? I want it to look clean. I want it to look, or not look, it's not just about aesthetic here, but it's about keeping it focused on simple data and simple keys, right? So that when you read it, you go, I know what this does, and you don't have to read a whole bunch of logic and verify that all of the edge cases are covered. So how does it work? Pretty simple stuff. Reads in the alias data. It takes in the options that you pass, and it reads in the alias data. It chooses the appropriate action that you've specified, right? Jar or whatever. And then it runs under the hood. It's just running the tools.build functions normally, the same way that you would, right? There is, inside of Clein, a jar function, and it does effectively what I had on that other slide, except it's also calling the, make ops of itself, where it reads in the alias data. Or it actually shells out to the deps.deploy. It just uses Clojure's sdeps to pass in the deps deploy and all of that so that it gets all the environment variables set up correctly. All right. And how did I build it? Well, I built it by, figuring out the specification, right? What was I looking to actually cover? What were the use cases I wanted to cover? And then what were the minimum set of options that I would need to handle, right? So like I've said now 30 times, the main, I'm going to need a main, I'm going to need the lib, right? the fully qualified namespace lib. I'm going to need a version. I'm going to need the source directories, the resource directories, the Java source directories if I'm going to cover that, where I'm going to have output, what the file name is for the jar or the Uber jar, etc. Right? Then I had to build the entry points for each of these actions. So the jar has to exist as like a, I have to have a function and wire it up through tools.cli. And then, because everybody loves a little bit of a yak shave, I got sidetracked by writing an action API for tools.cli that I hope to excise out of this and make its own library at some point. Where I noticed that, likewise to Clein, kind of like having these copy paste things, I was running into a situation with tools.cli where I was copy and pasting a lot of my inner logic for determining what my given action should be, right? When you're building like a CLI, you can pass in flags, but you sometimes also have like actions, where you say like, okay, jar, right? Like Clein space jar, no flags. And then that jar is just an argument that just sits there. And so determining what that jar is and tying it to a function is like an action or a command. And so then I ended up, spending a month tooling around, poking at building like a command action API for tools.cli that is sitting inside. It was fun. It was very silly. It's a fun way to spend some time. And then finally, I spent some time figuring out how to handle POM generation and manipulation to cover the provided scope or other kinds of scopes for POM generation for dependencies. The way that tools.build's API handles POM generation is very simple. It's based on like having the idea is that either it'll have a very bare bones POM, it'll generate a very bare bones POM, or it will take in like a sample POM and then write over certain keys and just like fill it in kind of ad lib style. And so both of those are not ideal. And so I spent some time, found some example code on the internet and was able to get it set up so that it steps through and is able to edit the appropriate dependencies and give them the appropriate scopes. That took a little bit of time as well. All right. So like what was my I wrote design philosophy, but that's not really it. It's more like what was the like goal, the aspect that I'm pointing at, the philosophy for building this, right? I wanted to stick to, this is for tools.build developers. This is for people who are going to be reading tools.build documentation, who are going to be asking questions on Clojurian Slack or on Clojureverse or at meetups, like, hey, I'm trying to generate a jar, I am using Clein, but like, how would I do this? And then somebody says, well, you want to use Java C -ops. In leiningen, that's Java C -options. And so when thinking about those two, my goal was, okay, let's stick with tools.build options, the keys, the names, when there's a conflict, when there's a difference, so that researching information about it is as simple as possible and as consistent as possible. It requires less effort on my part internally to convert between one or the other, and also means that the like backing out of using Clein is as simple as like copy and pasting your options into a new file, right? But then if there's no conflict, just use leiningen, right? Leiningen is rock solid. Leiningen has, I think, a pretty good API. I think that a lot of its decisions were smart, and ended up working out really well for so many years. That's one of the reasons it's so popular, is that it did actually do the damn thing, making it easy. And so relying on kind of the, like, instead of forging my own path and thinking I know better, just kind of like pick and choose from leiningen where appropriate to make this as easy as possible. And so before we kind of like, I think I'm going to show off some code, but before we show off code, I wanted to talk about some different features, highlight some of the features that I'll go into once we look at the code itself, that I think that make this better than a simple wrapper around tools.build, right? And the four that I've decided to highlight today are on the version handling, the POM manipulation I mentioned earlier, Java compilation, and the directory structure. And so with version handling, versions can be specified as text, right? You can just put in the text that you want, right? You can say, I want it to be, this is version 5, v5 or whatever. But you can also specify it in a separate file, and it will check that for you. It'll say, hey, does this file exist? If it does, slurp it up. And so that allows for having, as like CLJ Condo and Clojure LSP do, having like a resources file that you can point to as a marker of what is the version, like what is the current version, the current or latest version for this. And that can be a URL. That can act as like a URL for people to look at, and also for your project to, you don't actually have to modify your code to update the version. You can just modify the resource, and then in your application or your library, you can slurp that file. You can read that file in and get the version directly. And I think that that's really nice. I use that in Splint a lot. I mean, I use it the one time, but it works out great. It really simplifies a lot of stuff. It means that I don't ever have to modify my code to update the version. And then additionally to that, I set it up so that you can use kind of like in the Selmer tags style, use get count revs, which is a function from or get. Oops, it's supposed to be get count revs. I'm so sorry. Get count revs from tools.builds, which allows you to count how many commits there are. And a lot of libraries use this. A lot of the Clojure core libraries, all of Sean Corfield's libraries use this, where they'll have a major version, a minor version, and then a version that is what do you call it? A monotonically increasing number. That is the number of commits that is in the repo. Kind of like as a way to always have a differentiator, so that instead of having like increasing numbers of a minor or patch number, it's just the get count. And so that's handled through templating. And so you can put that in through the text or in your file. Both work. And then you can also specify either in the alias or in the command line that you want it to be snapshot. A lot of tools like to have like a snapshot version that you can push somewhere. And so snapshot is supported as well. POM manipulation was another aspect. I forgot that I had this. I would have held off on talking about it a second ago. But yeah, as I said, Maven and then Clojures, because of Maven, support this idea of like provided dependencies. Dependencies where you say, hey, I'm not going to include this as a direct dependency in my library, but if you're going to use aspects of this library, you need to provide your own. In LazyTest, I support a subset of the Nubank's matcher combinators library, right? But I don't want to bundle matcher combinators in my jar or in my Uber jar. That's much bigger. And I don't want people who are not going to use matcher combinators to be penalized for having to download it when they use LazyTest, right? If they run, Clojure-m test, I don't want them to have to see the little ticker that says, okay, you downloaded matcher combinators and all of matcher combinators dependencies. That's unnecessary. However, it is helpful for things like CLJ doc to have access to that information, to know when match recombinators is included. I have a namespace that is a match recombinators kind of stub that works at, or not stub, but like a bridge, right? And it requires match recombinators. And so when CLJ doc tries to analyze my project, it crashes because it's looking for that. It's looking for that library. It's looking for match recombinators. And so provided allows those dependencies to be loaded by either tools or by a user directly. They can include, and it says, hey, if you want aspects of this that deals with match recombinators in this regard, or in this situation, you have to provide it yourself. You have to include it as your own dependency. It's really nifty. It works out great. Tools.build does not support this, and I don't think they're going to support this. So what that means is you have to actually step in and manipulate the POM yourself after it's generated. So I figured that out. If you have if you include a provided alias, I should have put a picture here, but I can show it off. If you have a provided alias in your deps.edn with like dependencies, then Clein will read that, it'll load it in, and it will find those, and it will mark them as provided dependencies. Java compilation. So the Java C stuff that exists in tools.build is pretty powerful. It's pretty good. It requires you to keep track of where your files are, of course, as you should. But there's a lot of options, and there's a lot of ways that you can. It's just another area where there are many decisions that you can make, right? Are you going to copy them over? How are you going to copy the class files? How are you going to compile them, et cetera, et cetera? And this is mirrored by Leinigen's Java C options. And so what we do here is, additionally to the Java C stuff, there is a Java source directories, Java source dirs option that you can include that will act as the pointer for where the Java code should live. And that is what gets passed into the Java C calls in the tools.build calls. And so all of that allows you to say, I have Java code here, and I want to compile it with these options here. And then when you run, it will seamlessly run those and include them in your jars or in your Uber jars for you. Just one or two little lines. It's very nice. And then finally, the directory structure. As you saw earlier, there is it's very easy to kind of like keep all of your stuff kind of mangled, right? In deps.edn, you say paths with source and dirs, or source and resources, right? And then when you're compiling or when you're loading, you're just passing your paths around. It's very easy to kind of like keep them together in a way that you might not intend. And so Clein attempts to keep those separated by having, source dirs, resource dirs, Java source dirs that all kind of mirrors what's going on in Leinigen. And you can leave them out. If you leave out source, it's going to pull from your paths, right? It's going to pull from the top level deps paths. But by making it obvious, it allows you to kind of like keep track of all of those pieces, right? It'll copy over the resources into the jar, or it will compile and then copy the class files of the Java source dirs, etc. So yeah, here, let me show off some of the code. Oh yeah, these are my slides. This is how easy the Skittle tiny slides are. This is so sick. Look at this. It's so easy. And that's just reloading. Beautiful. I love it. How? I don't have a second window, so I can't see the comments. So how good are we on time? Are we okay, Bruno? It's okay. So, lazy test. Let me show off lazy test. This is what I had on screen earlier. So instead of having a complicated build file Here we have like a Clein/build. There's like my lib, right? This is like the pointer that it's going to be at. There's my main, right? A URL, a version. Oh yeah, I should have included this in my POM mentions. You can put license information in instead of like POM data. I support POM data and license. And so here I have the name and the URL, and this gets converted into the necessary POM data and included in the POM that is generated. And then I have my source dirs, my resource dirs, directories, my Java source directories, my Java C ops, right? And all of these are just passed along into Clein. So we'll scroll to the bottom. Here are the various CLI commands, subcommands, right? We can clean, we can generate a POM, we can generate Uber jar or a jar, we can deploy and install, and I'm actively working on export. This is all local. Here's my little CLI stuff. And so as you can see, this is very similar to what happens in a normal Java, what do you call it? A normal build.clj file. You've got like your clean. And so it's just like delete, right? This is just from tools.build API delete. Just delete a file or path, returns nil. Here's my write POM, right? I'm getting either the target dir directory or otherwise like a POM path. And I'm writing these out, writing the POM. This is necessary for uberjar, copying, compiling Java, right? When there are Java source directories, we're going to compile them. We're going to call them with the various things that we need, right? A class directory and a basis and the Java C options. The create jar looks exactly like it might if you were to write this yourself. The create uber jar looks very similar, right? Clean, copy, etc. And then the deploy here, I think the deploy is maybe the most interesting of these, where I'm actually building a deploy alias and then shelling out to Clojure with this. And I'm doing this because if somebody doesn't want to deploy, similar to the provided, I don't want them to have to pull in deps deploy themselves, right? And this allows me to pass through the username and password for the and pass directly to the function. I can pass directly to the function the username and password that I'm pulling out and getting the artifact and the POM and all that, right? And I pull these out and I deploy. And then same with install, and I'm working on export. As you can see, it's empty. So then up here is kind of where like the meat of the configuration work happens, where I'm getting a basis, right, for Clein build, and then I'm conforming the specs that I built. And what's conformed is a map that has all of the items kind of like smushed together as the spec conform works, right? Spec conform is this cool way of taking input data and not just validating it, but also shaping it. So giving like the OR branches their separate keys. It's very nice. So I can say like, hey, if it's not valid, then I'll throw an error. Otherwise, we just go through and we build, we kind of like shape it up, right? So like get the version. If there's going to be a get counts, we're going to do that. Otherwise, here's snapshot, the source directories, the resource directories, etc. Right? Supporting like your file jar or uber jar name, etc. Right? And in the build POM, we have to, we're either like getting the POM data or setting out a license when a license exists. What else? I think that's, I think that's it.